Difference between inertial frame of reference and non-inertial frame of reference. For inertial frame of reference, uh, definition will be what? Inertial frame of reference. Inertial frame of reference is a frame inertial frame of reference is a frame of reference or a set of, that is a set of rigid, a set of rigid axis which stays at rest, which stays at rest, which stays at rest or remains remains in uniform motion, remains in uniform motion, remains in uniform motion with respect to another assumed inertial frame of reference. With respect to another assumed inertial frame of reference. Assumed inertial frame of reference. Frame of reference. Inertial frame of reference is a frame of reference that is a set of rigid axes which stays at rest or remains in uniform motion with respect to another assumed inertial frame of reference. Now we can draw a set of rigid axes. So this is vertical axis, and this is another axis. We have to draw three-dimensional axis. We can draw another axis in horizontal plane. So we can assume two axes in horizontal plane and one is vertical axis. This will be another horizontal axis. And this can be assumed as assumed inertial frame of reference. This set of axes. Set of axes can be assumed as inertial frame of reference, and we can draw another set of axes denoted by yellow color. This is another set of axes. This is another frame of reference. The former is assumed inertial frame of reference having z axis, and another frame of reference is z prime axis. O and O prime are the origin of the two sets of axes. Can extend this axis, that will be the x-axis of the frame of reference, x-axis of the frame of reference which is assumed later, that is x prime, that was y and y prime, and then this axis, extended axis, is x prime. The new set of axes which is assumed later will be moving with constant velocity and without any acceleration or zero acceleration. we can assume that this new set of axes having z prime, y prime, and x prime axis is moving with constant velocity and zero acceleration. That's why this new set of axes denoted by yellow color can be assumed as inertial frame of reference with respect to the another inertial frame of reference. As this new set of axes is moving with constant velocity and zero acceleration, that's why uh, this new set of axes is inertial frame of reference. On the right hand side, for non-inertial frame of reference, the new set of axes having three axes x prime, y prime, and z prime, that is moving with variable velocity and definite acceleration, and this acceleration may be positive or negative. So in that case, this new set of axes denoted by yellow color can be assumed as can be and this axis can rotate with an angular velocity omega. Omega is the angular velocity with which the new set of axes can rotate, and this new set of axis is what non-inertial frame of reference, because it is moving with variable velocity and with certain acceleration with respect to the initial set of axis or with respect to the assumed inertial frame of reference. And new set of axis or non-inertial frame of reference denoted by yellow color has variable velocity, certain linear acceleration, it rotates, it can rotate, it has certain angular velocity and angular acceleration alpha also. This new set of axes should have variable angular velocity, angular acceleration alpha, variable linear velocity v, and tangential or linear acceleration a. That's why this new set of axes is known as non-inertial frame of reference, where this non-inertial frame of reference can rotate or can spin with respect to the pre-assumed non-inertial frame of reference denoted by violet color. That's why this new set of axes or in a non-inertial frame of reference should have certain angular velocity omega, linear velocity v, certain linear or tangential acceleration a, and certain angular acceleration alpha. An inertial frame of reference should have zero acceleration, but a non-inertial frame of reference should be moving with certain linear acceleration with respect to assumed inertial frame of reference. Now, the new set of axes, which is denoted by yellow color, is non-inertial frame of reference. Non-inertial frame of reference, which is moving with certain acceleration certain acceleration a, variable velocity v, which spins with certain angular velocity omega and certain angular acceleration alpha. This is not number two difference between inertial frame of reference and non-inertial frame of reference. Newton's laws of motion is valid for inertial frame of reference. Newton's laws of motion are valid. Newton's laws of motion are valid in inertial frame of reference. That means these laws are applicable for inertial frame of reference. Inertial frame of reference. and right hand side Newton's law of motion are not valid in non-inertial frame of reference. Newton's laws of motion are not valid, will not be applicable, or will not hold true. Newton's laws of motion will not hold true in non-inertial frame of reference. Non-inertial frame of reference. Non-inertial frame of reference. Now we can return to the first non-inertial frame of reference between inertial frame of reference or non-inertial frame of reference. Non-inertial. On the right hand side, number one, frame of reference. The definition of non-inertial frame of reference. Frame of reference. Non-inertial frame of reference is a frame of reference. 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 A frame of reference which is a non-inertial frame of reference or which travels with certain acceleration, which is accelerated, non-inertial frame of reference is a frame of reference which is accelerated with respect to another assumed inertial frame of reference. Another assumed inertial frame of reference. Inertial frame of reference. So in this diagram, set of axis for left hand side inertial frame of reference, angular velocity omega and angular acceleration alpha will be 0. We can return to the number one difference for non-inertial frame of reference on the right hand side. Number three, it should be another assumed inertial frame of reference, and on the left hand side again we have to write another assumed inertial frame of reference. In the diagram, the former, that means the set of axis which is denoted by violet color, should be assumed inertial frame of reference for the right hand side and also for the left hand side. That means an inertial frame of reference should be considered with respect to another assumed inertial frame of reference. Again, non-inertial frame of reference will also be considered with respect to another assumed inertial frame of reference. On the left hand side, the force acting on a body in inertial frame of reference. The force acting on a body in inertial frame of reference is given by F equal F real, means in this case force is equivalent to the real force experienced by the body or the real force acting on the body, is given by F equal F real, means force acting on a body in inertial frame of reference is equal to real force experienced by the body. No fictitious force acts on the body in inertial frame of reference. Where F real is the real force, as an example, gravitational force of attraction or electrostatic force of repulsion or attraction or magnetic force, etc. Gravitational force, electrostatic force of repulsion or attraction. Gravitational force is always gravitational force of attraction. Then electrostatic force of attraction or repulsion, electrostatic force, magnetic force, etc. These are the real force experienced by the body. And in inertial frame of reference, only real force acts on the body, due to which the body will be accelerated, where F real is the real force. As an example, gravitational force, electrostatic force, magnetic force acting on the body. On the right hand side, on the right hand side, the force acting on a body is given by the force acting on a body in non-inertial frame of reference is given by the force acting on a body in non-inertial frame of reference is given by non-inertial frame of reference is given by F equal F real minus F fictitious F fictitious. So there should be fictitious force or pseudo force acting on the body, and net force acting on the body will be F real minus F fictitious. F equal F real minus F fictitious, where F fictitious is F fictitious is where F fictitious is a number of fictitious or pseudo forces, a number of fictitious or fictitious forces, a number of fictitious forces acting on the body, acting on the body. Number 4, no fictitious forces. No fictitious force acts on the body in inertial frame of reference. No fictitious forces such as centrifugal force, Coriolis force, Euler force, etc. Coriolis force, Coriolis force, Euler force, etc. And this force are generated due to the rotational effect of the inertial frame of reference. No fictitious forces such as centrifugal force, Coriolis force, and Euler force, etc., acts on the body. Acts on the body. Whereas number 4 on the right hand side, a number of fictitious forces, a number of fictitious forces such as centrifugal force, Coriolis force, centrifugal force under bracket Fc prime. It is denoted by Fc prime, bracket closed, comma Coriolis force under bracket F Cori, F core, Euler force, if oil, etc., act on the body. Act on the body. Now, Centrifugal force, the expression of centrifugal force is vector Fc prime equal vector Fc prime equal m vector omega cross vector omega cross vector xb. Vector Fc prime equal m vector omega cross vector xb, where uh, omega is the angular velocity of the non-inertial frame of reference with respect to assumed inertial frame of reference. Fc prime equal m vector omega cross vector xb. This is the expression of centrifugal force vector. Centrifugal force vector. Centrifugal force. Vector Fc prime. It should be vector Fc prime on the left hand side. Now the expression of Coriolis force is vector Fc prime. It should be vector Fc prime, arrow Fc prime. Now magnitude of the centrifugal force is m omega square xb. That is mass into square of angular velocity omega into xb, means perpendicular distance of the body from axis of rotation. Vector F Cori, if vector F core means expression of Coriolis force is 2m twice of mass vector omega cross vector vb, vector omega cross vector vb. This is the expression of Coriolis force. This is the expression of Coriolis force. This is the expression of Coriolis force. Vector F core equal to m vector omega cross vector vb. This is Coriolis force, where F core equal to m omega vb. Magnitude of Coriolis force is F core equal to 2m omega vb, where F Euler, the expression of Euler force is F oil, F ul, vector F ul equal m ddt of vector omega cross vector xb, ddt of vector omega cross vector xb. So magnitude of Euler force is F ul m d omega by dt xb, d omega by dt xb. So these are the expression of three fictitious force: centrifugal force, Coriolis force, and Euler force. F Euler equal m d omega by dt xb. Therefore, F equal means net force acting on a body is F real minus vector F equal vector F real minus vector Fc prime minus vector F core, means Coriolis force vector, minus Euler force vector, that is F EUL, vector F EUL. Now putting the expression of these three forces, we get net force acting on the body as vector F. Therefore vector F equal vector F real minus F vector omega cross vector omega cross vector xb vector omega m vector omega cross vector xb minus, now putting the expression of Coriolis force, 2m omega cross vector bb minus m ddt of vector omega cross vector xb. So this is the expression of net force vector acting on a body. Now if we mention the example of inertial frame of reference and non-inertial frame of reference, for inertial frame of reference, example is what? A coordinate system attached to earth. A coordinate system attached to the earth a coordinate system attached to the earth is inertial frame of reference is inertial frame of reference inertial frame of reference. A coordinate system attached to the earth is an inertial frame of reference it is observed if it is observed from earth. A coordinate system attached to the earth is an inertial frame of reference if it is observed from earth. Again, a coordinate system or same coordinate system attached to the earth attached to the earth is not an inertial frame of reference, that is a non-inertial frame of reference non-inertial frame of reference non-inertial frame of reference if it is observed outside the earth, means if it is observed from moon. If it is observed from moon, if it is observed from moon, as earth rotates and accelerated and is accelerated with respect to sun, is accelerated with respect to the sun, assumed inertial frame of reference. The sun is an assumed inertial frame of reference. Now in the middle, below difference number 4, what we can write, fictitious force comes into play. Fictitious force comes into play fictitious force comes into play due to translational and rotational effect of the frame of reference with respect to assumed inertial frame of reference. Fictitious force comes into play due to translational and angular acceleration. Translational and angular acceleration of the non-inertial frame of reference with respect to assumed inertial frame of reference. In this case, for non-inertial frame of reference, real force and fictitious force, both the forces act on non-inertial frame of reference. Real force and fictitious force act on the non-inertial frame of reference. Fictitious forces act on the non-inertial frame of reference. But on the left hand side, if we consider inertial frame of reference, only real force will be acting. But for inertial frame of reference, only a real force is acting.